Question 7. A triangle has one side of length 10 and another side of length x. The perimeter of the triangle is 26 centimeters in length. Fill in the length of the third side in each case on the diagram below. So we've got 4 plus 10, which is 14. So 26 take away 14 gives us that this here is 12 centimeters. And likewise, I have the same idea here. I got 10 plus 9, which is 19. So 26 take away 19 gives us that side there is 7 centimeters. Okay. Question 7b, find 3 values of x that make the triangle an isosceles triangle. So the perimeter is tied in at 26. So our first option is that we could have x as being 10 centimeters. Because then I've got this side here, which is already 10 centimeters. X as being 10 centimeters makes it an isosceles triangle, which will have the leftover side of being 6. Because it has to add to 26 and I know this side has to be 10, I could also have 8 and 8, because if I take 10 away from my perimeter of 26, I'm left with 16. Dividing that by 2 gives me 2 sides of 8, so it could also be 8 centimeters. And then the last one, which is a little bit tricky to think of, is, well, if I make this a certain length so that this side and that side in my triangle become isosceles. So if that's 10 centimeters, let's make that 10 centimeters, which would have made x 6. I think that's the most common one that was missed that year. Question 7c. Okay, so we have this graph of the area of the triangle for all values of x between 3 and 13. The point A is marked, so there we have it there. So A is the point of the graph at x equal to 4, so it represents the triangle in diagram A. Use the point A on the graph to estimate the area of the triangle in diagram A. So literally A is on the graph, we know that's when x is equal to 4, so the area is found over here. So I'm going across there to find out what I think this is equal to. So A is there, and it's going straight across. Okay, so that is probably not great. Slightly more than 15, 16, 17, 18, a little bit more than 18.5. Let's say 18.6. 18.6, 18.7. I'll say 18.7. But they'll be very forgiving with that there. I've shown that I've used the graph. That should be enough. And they'll have a nice little thing. They'll probably accept anything over 18.5 and less than 19. Okay, plot the point B on the graph that represents the triangle in diagram B and label the point B. Well, in diagram B, x is equal to 9. So I just have to go to where x is equal to 9 and then go up and where it hits the graph. That's where my B is going to be. Now I'm going to do mine as a little x, so it's nice and accurate. So that's my point there. Okay, and I've labelled it point B. And then finally, the graph is symmetrical. Draw the axis of symmetry on the graph in the diagram above and write down the equation of the axis of symmetry. So if I look at this, it's going to be symmetrical right in the middle, which is at 8. So I'm going to draw my line straight up there. Okay, so that's part of the question done, and now I just need to decide what is the equation of that line. Well, it's a vertical line, and the only thing we know about it is that x is equal to 8. Okay, y doesn't matter at all. A vertical line is always going to be x is equal to something. A horizontal line is always going to be y is equal to something. Okay, so that's a nice way of differentiating what way it is that we need to do this. So there's no slant in this at all, it's just that x is equal to 8, and that is the equation of our line. So again, to reiterate, any vertical line has the equation x is equal to and whatever it is equal to. Okay, this vertical line goes through 8 all the way up. X is going to be equal to 8, so that's why the equation is x is equal to 8. Okay, so question 7d. When x is equal to 5, the triangle has sides of length 10, 5 and 11. Show that it's not a right angle triangle. Okay, so right angle triangle, there's two things we know about it. It follows Pythagoras' theorem. It also follows SOHCAHTOA for trigonometry. So given that we're just dealing with 3 sides, we know we're definitely dealing with Pythagoras. Okay, so if it's a right angle triangle, then the longest side squared is equal to the other 2 sides squared and added together. So if I can show that this doesn't work for these 3 sides, I can show that it is not a right angle triangle. So we have that the longest side there is 11. So 11 squared, and we're going to see if that's equal to 10 squared plus 5 squared. Because I've been asked to show, I'm working each individual bit out. So 11 squared is 121, and we're going to see if that is equal to 10 squared, which is 100, and 5 squared, which is 25. So 121 and 125, of course these are not equal, so I can just cancel. This is the symbol for not equal. So 121 does not equal to 125, and we're going to make our little conclusion. Therefore, with our 3 dots, this is not a right-angled triangle. Okay, question 7e. The diagram below shows a triangle with the biggest area. So 10, 8 and 8. Work out the area of this triangle. Give your answer in the form of 5 root n centimeters squared. Okay, so we're going to leave it in the third form. Okay, so the key thing here is that we are looking for the area of this triangle, and our area for a triangle is half the base times the height, or as it appears in our formula tables, a half AH, where A is the base and H is the perpendicular height. Okay, so I'm going to have to find the perpendicular height at this point. So we're going to have to find out what H is. Okay, in order to do that, we know we've got a right angle triangle. I have this side. I know that because this is an isosceles triangle, it splits this base in 2, so this is going to be 5 centimeters down here. So I can use Pythagoras' theorem to find out what H is. Okay, so C squared is equal to A squared plus B squared, where C is the largest side and A and B are the other 2 sides. So the largest side is always across from the right angle, so it's going to be 8. So 8 squared is equal to 5 squared plus H squared. So that gives me that 64 is equal to 25 plus H squared. Take 25 off both sides, and that is going to be 39. So 39 is equal to H squared. So H is equal to the square root of 39. Now, I'm going to double check both of those things on my calculator. The fact that 64 take away 25 is 39, and it is. And I'm going to square root 39 to see if it can be simplified at all, and it can't. It just stays as the square root of 39. So that is my height. So now I can plug that into my formula for area. So we know that area is a half of the base times the height, which is a half of, now the whole triangle has a base of 10, and the height of the triangle is root 39. Now I am going to just plug this straight into my calculator, and it'll give me 5 root 39 as my answer, which is nice. Half of 10 is going to be 5, and that multiplies by root 39. I'm just going to say, if you check that on the calculator, that's how it's going to come out, which is convenient because my answer was asked to be given in the form of 5 root n. I have the 5, just so happens that my n in this case is 39, which is a natural number, so I can do all those double checks, and of course remembering to have my units. And that is my final answer.